All right, lesson number 8 is on modeling and equation solving. So math modeling means story problems. So we have some story problems. So in order to create a model, in order to solve a problem, we often need to draw some kind of picture and assign variables that make sense. So A for area, P for perimeter, L for length, W for width. So just because there are words in a problem doesn't mean that it's a hard problem. You guys are in pre-calc now. You can do this. You're all looking at me and rolling your eyes. Great. Awesome. It's going to be a wonderful morning. All right, so number 1. So it says Lauren is deciding between 2 jobs at the mall. She plans on working 30 hours a month. One job pays her $300 plus 5% of her total sales. Did you guys know that you can get a certain percentage of your commission? Have you walked into the mall before and then people are like, hi, how can I help you? That's usually why. While the others pay her $200 plus 8% of her total sales. So how much would Lauren need to sell in order to make the second job more attractive than the first? Okay, so I don't have like an hourly rate or anything. They're just saying you're working 30 hours, and during that time, we're going to pay you $300. So she's making, $10 an hour. All right, so let's see. So if I have 300 and I add 5% of the total sales, this is where we need to define a variable. This is the only time I don't use an S. I would use an X because my S's look like 5s. So we're going to say let X equal her total sales. So we want to know when the second job is better than the first job. So we can do this with a greater than or equal, or like a less than or equal to in this case. Or I don't care. If you just want to do an equation, that's fine. We just have to interpret it at the end. Okay. So we can do equals, and we can say $200 plus 8% of our sales. Now we're going to just solve this out. We're going to subtract the 200 over and we get 100. We're going to subtract the 0.05 over, so 0.08 minus 0.05 is 0.03x. And we can multiply, or we can divide that over. So if I have my 100 and I divide by 0.03, I get 3,333.33. Now this is money, right? So we're going to round to 2 decimal places. Okay, so let's think about it. So the first one, if she doesn't make a lot of sales, it's better to get that $300, right, than 200. So if she's not selling anything for the month, she sells $0 worth of stuff, it's better with the first job, right? So our turning point is happening when it's 3,000. I should have done a nicer number. This is rough. $3,333.33, right? That's the turning point. That's when it's better to get less up front and more from your sales. Does that make sense? So if she sells that much worth of clothing, so if people come in and they're like, all the total people throughout that month spend over $3,000, that's good for her. Okay, so that's our turning point. So she would need to sell at least $3,333.33 worth of clothes, or worth of sales. Yeah, that's probably, you can probably make those sales in a couple days. All right, so number 2. So how much of a 12% acid solution must be mixed with a 20% acid solution to get 20 liters of a 15% acid solution? So if you guys had me in Algebra 2, I always do these a certain way. Do you guys remember how we do them? Like little buckets? You guys know what I'm talking about? Okay, so you can draw little squares, or if you're fancy and you can draw little cylinders. Okay, and inside here we're going to put the percentages, and down here we're going to put the amounts. Okay, so let's think about what this means. So I'm not going to use numbers that are in this problem, so everybody just look up here. So what if I had 100 liters of something that was 12% acid? How many liters of acid is in that? So it's 100 liters total. There's stuff mixed in there, water and acid, and only 12% of it is acid. How much is acid? No, but that's how much would be like water or other, right? It's 12 liters. Does that make sense? If I'm saying 12% of 100 liters is acid, that's why we take this number that's in here, the 0.12, the 12%, and we multiply by 100. We get the amount of acid in each thing. Does that make sense? That's what we're doing when we do that. So it's saying how much of a 12% acid, so you can write 12% or you can write 0.12 if you want, should be mixed with a 20% acid solution to get 20 liters total of a 15% acid solution. So we have 20 liters there. Okay, the percents never add up. I can't add something that's like 50% acid to something that's 50% acid and be like, oh, it's now 100% acid. It would still be 50% acid, right? Does that make sense? So if I have something that's 50% acid and I add it to something that's less acid, like I dilute it, I add it to something that's 20%, it's going to be somewhere in between 50 and 20, depending on how much we've diluted it. If we add a whole bunch of that second mixture, it's going to be really diluted, right? It's going to be closer to the 20 than it is to the 50. Does that make sense? Okay, so when we talk about the amounts, though, amounts always add up. So if I had 8 liters of something and I added to 12 liters of something, I do get 20 liters of something, right? So these numbers down here have to add together to be 20. So let's make one of them x. So we're saying how much of a 12% acid solution? Let's make that our x. And I said these numbers add up to be 20. So I could do x and y and 20, but I want to make it one variable. How can I make it one variable? What do I put here? Yeah, it's 20 minus x. It's the rest of the 20. So if that had been 12, the other one's 8. If it had been 11, the other one's 9, right? So this is going to be 20 minus x. So do these add up? You can check off to the side. X plus 20 minus x, does that equal 20?
Is it 20 or 0.2?
It's 0.2 for the percent acid, but it's the amount is 20 minus x. And those add up, right? X plus 20 minus x does make 20. Okay, now we create our equation. So we do this by talking about the amount of acid in each thing. So the amount of acid comes from multiplying these together. So we're going to have 0.12x added to 0.2 times 20 minus x equals the 0.15 times 20. And then we solve it out. So we do 0.2 times 20, so we get 4 minus 0.20x. 0.15 times 20 is 3. We continue subtracting, so when I combine these two terms, so be careful, we do get negative 0.08x. And when we subtract the 4 over here, we end up getting negative 1. So when we divide 1 by 0.08, we get 12.5. So we have 12.5 liters of 12% acid. And if you want to find the other, how much of the 20% acid would we have? 7.5, yeah, perfect. So sometimes I ask for both. How much of each? Because they add to be 20, right? So subtract from 20. Do you guys remember those? Is it all coming back? All right, how about these ones? One positive number is 2 times another positive number. The sum of the two numbers is 310. Find the two numbers. Okay, so one positive number is 2 times another positive number. So you could do this with x's and y's if you want to. So you could say, let my two numbers be x and y. So one positive number equals 2 times the other number. The sum of the numbers, x plus y, is equal to 310. So this is a little bit harder than what we did in Algebra 2. So we need to somehow solve for y. So we can solve for y and say it's x divided by 2. Or actually, we have x already. Let's just use x. We have x equals 2y, right? So we're going to take this 2y and we're going to replace the x with it. So we're going to say 2y plus y equals 310. So we get 3y equals 310. And when you divide that out, you'll see that it doesn't go evenly. So I get 103.3 repeating. Is that okay? Is it a positive number? Totally fine. So x then is going to be 2y, so 2 times 103.3 repeating. So it's going to be 206.6 repeating. Those are our two numbers. Okay, so a little bit harder than algebra 2. Algebra 2 is always like x equals 5, y equals 10, right? They were always easy. All right, so a large painting for the IMA is 3 feet longer than it is wide. So let's draw this out. Doesn't matter which one's your width and your length. So let's say width and then 3 feet longer than it is wide. So I can use L, or I could say, oh, W plus 3, right? If the wooden frame is 12 inches thick, so going all the way around, we have 12 inches. And the area of the frame is 208 feet squared. Find the dimensions of the painting alone. Okay, so what do you guys notice about this problem? Are there any like red flags? The frame, what do you mean? How about, should I be doing like, should I say this distance is 12 here?
Yes.
Trick question. Look for it.
You would need that.
Yeah, you would need that. Read through. 3 feet longer than it is wide, 12 inches thick, 208 feet squared. 12 inches. Ah, we need to change that. Okay, so look at our units. Feet, inches, feet squared. So what do we probably want to change it to? I would change it to feet.
1 foot.
Okay, so both of these are 12 inches, which is 1 foot. So how much did I really add? So I added 1 inch here, or not 1 inch, 1 foot, 1 foot and 1 foot. So what is this total distance up and down? How would I write that? W plus 2, right? How about for this one? Same idea, we still have 1 and 1, right? So instead of W plus 3, we now have W plus 5. Because we added 1 to each side. We added 2 total. And then we talk about the area being 200 square feet. Well, how do we represent the area then of the whole thing? The frame and the picture together would be our width times our length, W plus 2 times W plus 5, has to equal a total of 208. Where did the 208 come from?
No, the 2. W plus 2.
Because we had W before, so this distance was W, and we added 1 here and we added 1 here.
Oh.
Does that make sense? All right. So think about the steps you would have to do if you were doing this without a calculator. What would we do? We would FOIL it out, right? So we do W squared plus 7W plus 10 equals 208. So let me write this. You guys don't need to write this because I'm going to show you another way. I would do W squared plus 7W plus 10 equals 208. I would subtract our 208 over. I would combine negative 208 and 10. I would then try to factor, and it wouldn't work, and you would cry. I don't think it works. Could, maybe, I don't know. So if it doesn't factor, then you would do your favorite quadratic formula. Do we want to go through all that work?
Yes.
No. So we can do this a couple different ways. We're going to use our calculator to help us. So I'm going to show you 2 different ways to do this on your calculator. So go ahead and get your calculator out. See, pre-calc is exciting because once you learn how to use the calculator, there's no turning back. You get to use it all the time. Except when I give you non-calculator quizzes, right? Zach was asking, do I get a calculator? Yeah.
What?
Surprise! All right, so one way to do this is to set the left side of this equation, like this W, so this way you don't even have to multiply it out. So W plus 2, so I'm going to put in X plus 2 times X plus 5 and for Y1. Then for Y2, I'm going to put 208. So I put the left side of the equation in for one part, and I put the right side of the equation in for the second part. And then we hit graph. And we see part of it, but not all of it. Okay. Think about that second equation. What about this second equation, this y equals 208? Tell me what that looks like. A line. What kind of line? A horizontal line. Like, don't use the word, just use your hands. Yeah, a horizontal line. Through what y value? 208. So this is where you would have to think about the window. So right now, when we graph it, it starts at negative 10 and goes to positive 10 for x. And for the y, it starts at negative 10 and goes to positive 10 for the y. So what do we want to do? How do we want to adjust the window? We want to take our y value and make it go up really high. So I would do like 250. So now we see that parabola graphed again. And then we see a line going through. Okay, so what's wrong with our graph now? We want to find where they cross. Yeah, we probably need to scooch it over a little bit, don't we? Scooch. All right, so let's do window, and let's make our x max. Maybe we make that like 20. X in this problem is the width of the frame. Do you think it's going to be like 300 feet long? No, that would be like the whole IMA. It's probably somewhere between like 0 and 20. All right, this is the magic point we want. What about the other one? Tell me why I don't care about that other one. Because negative, and we're not talking about the negative length for a frame, right? Okay, so let's find that point. So how do I do this? I do second. Basically, everything we need on the calculator is under second trace. So do you guys see trace? Everything you guys need is under there. And then we're going to go down to intersect, because we're finding an intersection point. We hit enter. We trace along here. We get to where we think it's intersecting, so it says trace along the first curve. That's what it's saying. Hit enter. Then it's like trace along the second curve. Is your second one already there? So if it's already on that point, hit enter again. Yes, hit enter again. It gives me that the intersection point is 11 and 208. Okay, W is what we were trying to solve for. W is equal to 11. So I guess it did factor if we had tried to factor. Yeah. I don't know. Oh, it's TI entire. I'll have Mrs. Hogan help you. I don't know. I'm not the best with them. So W is equal 11. So then what is the length? If this distance right here, W is equal to 11, what's the length?
14.
14, right? So it's going to be 11. So the painting is 11 feet by 14 feet. Still pretty big. All right, what if I asked for the frame? What would that be? Yeah, 16 by 13, exactly. So I'll say 13 by 16, because then you would be plugging in for W plus 2 and W plus 5, right? So we did ask for the dimensions of the painting, though, so it's up to you if you could have that or not. All right, is this making sense? All right, oh, I did want to show you one more way. So another way that you could do this problem is you could subtract that 208 over. So 10 minus 208. So negative 198. So you could get to the point where you had W squared plus 7W minus 198 equals 0. That does factor. I should have known it factors. But that's okay. I'm trying to teach you how to use the calculator for this section. Okay, so let's say I went back to my calculator. So try this along with me. There's kind of a convenience of things being set equal to 0. Okay, so if I do y equals and I clear out these two functions and I instead did x squared, you guys good back there? Plus 7x minus 198. And then I don't put anything in for y2, I just hit graph. Now you're finding where it's crossing the x-axis. So think about this. If I was back at my standard window, so if I did zoom 6 to go back to that negative 10 to 10, I don't quite see it. So this is an upwards parabola. I know it's an upwards parabola. And I don't quite see it, but if I zoomed out maybe, and hit enter, oops, there it is. So it's graphing that, and I would find this point right here. So if I was finding that intersection point with the x-axis, that's called a 0. So I do second trace 0. I'd get on the left side of it. Have you guys all done this before? I think you have done it before. I'd get on the left side of it. I'd get on the right side of it. And then I'd get as close as possible to it and hit enter. So it says 11, 0. So that's sometimes is easier for students because they don't have to adjust that window very much. We know it's along the x-axis. We just have to kind of adjust the x values, the x min, x max, instead of the y min, y max. So I don't know how many times I have students that, like if they put this in for y1 and the second one in for y2, they don't know to go up to 208. They're like, wait, why do I not see this? Well, because the y value is way up there at 208. Okay, so sometimes you have to adjust that window. All right, so I'm going to pause here so you guys can have your break. So number 5 says, a gift shop in Zionsville is creating boxes to be decorated and sold in their stores. So they want the total volume to be 484 cubic inches. Squares are to be cut out of a 20 by 25 inch piece of cardboard, and the flaps are to be folded to make an open box. So a lid will be made in a separate. So we call it open box when there's no like lid on it. So what size of squares should be cut from the cardboard? So do you guys remember, I've done this before where I've cut out like the corners of squares, or the corners of like a rectangle. Those of you that weren't in my class, can you visualize what's happening here? So we're cutting out squares in the corner so that we can fold up the flaps. So we can fold up the flaps to make some kind of box. And it has to be squares, because if you cut out something that's like a rectangle out of the corner, right, one of those flaps is going to be taller than another flap. So let me kind of sketch this out here so you guys can see it better. So if I cut out something that's a rectangle, then it's going to be a box where like part of the box is really tall and part of the box is it's going to be really a messed up box. Do you guys get that? It's not going to look right. So it has to be squares. And the bigger squares that you cut out, the taller the box is. So if I cut out squares that were like this, whoops, that's not a square, that's a rectangle. I don't want to do that big. So like squares like this becomes the height of the box. Okay, so there can be like flat boxes, like maybe to hold like a t-shirt or a tie or something like that, really flat boxes. But there could also be really tall boxes, like a hat box. Do you get this concept? You're just staring at me like I'm a crazy person. All right. So anyway, so we're cutting these squares. So these are going to be x by x out of something that is 25 inches originally on one side and 20 inches on the other side. So I want you to give me the length, width, and height of this box. So think about the length, width, and height. So we're folding it. So it looks like this. This is one of the distances. This is one of the distances. And then the height is x. Okay, so give me the length and the width. (20 minus 2x) can give me 1. What about the other one? 25 minus 2x, exactly. So we have 20 minus 2x, and we have 25 minus 2x. Doesn't matter which one's which. So when I talk about the volume of the box, the volume is the length times the width times the height. So our volume, it says we want it to be 484 cubic inches. And our length was 20 minus 2x. Our width was 25 minus 2x. And our height was x. So again, you can spend a lot of time multiplying this all out, but I am letting you use your calculator. So this is kind of like AP Calc. We have, on the AP Calculus exam, there are, I don't know, like 2/3 of the exam is non-calculator, but 1/3 of it is calculator. So you want to make these choices on if it's faster to just use your calculator. In this case, I don't want to FOIL that all out. I don't want to subtract the 484 over and then try to factor. That seems very time consuming. Okay, so what we're going to do is you could subtract the 484 over to the right and not worry about the window as much and have it set equal to 0. Or you can do like we did on the last one and do a y1 and a y2. Just adjust your window so it goes up past the 484 for the y value. Either way, doesn't matter. Okay, so let's say we do the y1, y2. So we're putting like 484 in for one of them, and then for the other one we're putting 20 minus 2x, and then 25 minus 2x, and then x. Okay, and when we do our window, we definitely want it to go up past 484 because that's the second line. So we want to go up to like, let's say 500. And the x values, if you think about the x values, x is, what is it? It's the height of this box, right? Do we think it's going to be like negative? No, it can't be negative. So we could start it at 0. And if you want to, you can go up to like even 20. I think it's going to be smaller than 10 personally. What does it have to be smaller than? Looking at our picture. So if this is 20 here, and we cut out a size of x, what if I cut out a really big square, and then another really big square, and they went right up against each other? There's no box that's created, right? So let's think about this. If we have 20 here, what would be bad? What's too big to cut out? 10, right? So really with our y equals, or our x values, I mean, we could go up to 10, and that would be fine. So we don't even have to do 20. So when we hit graph, we see that y equals 484 up there. Then we see this. So we want to know its intersection point, and we have 2 different locations. Okay, this one's still okay because we went up to 10. Remember, 10 would be the worst case scenario. But we could have anything less than it. So we actually have 2 answers for this. So we're going to do second trace, and we're going to find the intersection point. Actually, let's make the window go up a little bit more. Let's go up to like 600 so we can see it a little bit better. You always want to get like, I don't know, you don't want to have a point that's off the, okay, so we can see it a little bit better. I think it's fine if we did intersect, but, okay, so do a second trace, yeah.
I have 3 intersections.
Ah, so you have 3. Did you go out to 20? Yeah. Okay, so the one that goes out to 20, so she says she hit 20 and she hit graph, and it's a cubic function, right? If you multiply out the volume, like the length times width times height, there were 3 different x's in there, so it will go up 3 times. But the thing that's bad about this one is it's more than 10, and we can't cut out more than 10 from both sides because it was only 20 inches long. Sorry. So if we have 20 here, you can't cut in 10 and in 10 because there's no like thickness to the box then. It's just like an envelope then. You would fold it over. So we would want to be less than 10. So let's just find the first 2. So do second trace, intersect. And we'll go along the first curve. And then we'll hit enter. And then it will say second curve, and it's still in the same spot, so I hit enter. And then guess, same thing. So it looks like 1.222. So x equals 1.222. Let's find the next one. So second trace, intersect. Go over to the other one. Enter, enter, enter. 6.871. Did you guys get those numbers? What was 6.871? Yeah. Okay, so those are the 2 possibilities. So if you want to write like x1 and x2, you can do that, or you could just say x could equal this or this. So those are our 2 possibilities for the size of square from that box. And it's inches, so if you want to put like little tick marks for inches, you can do that. Okay, does that make sense? So we want to use our calculator as much as possible. So on the homework, as long as you're setting up the equation and stuff, you can use the calculator. You don't have to like do all the stuff that we did in Algebra 2 to try to do it by hand. Yeah, Greta?
So why are there 2 values?
Okay, so why are there 2 values? So let's think about the types of boxes that are created. So if I had one that was, so if I started out with my 20 by 25, and I cut out a 6-inch square, and a 6-inch square from each side. Okay, think about the box that's created. It's going to be a box where the height is pretty darn big. Okay, it's going to look like that. I would call that like a hat box or something. Okay, so it's like a taller box, maybe for like a cake. All right, but if I had something that was 20 by 25 and I cut out a small, like a 1-inch, that's going to be like a shirt box. So it's going to be one that's real shallow, but wider. Okay, so it's going to be like that. Does that make sense? So there's 2 different boxes that could be created to have that volume. So then that Zionsville company would just say, well, what kind of box do we want? We want it to hold that kind of volume, but do we want it to be like a taller box or a wider box? Okay. All right. Yeah.
Can you go back like to your window? Because I did not like my
Yeah, window, we did 0 to 20 just so you could see the other one, but really it's only from 0 to 10 because we're kind of thinking about the domain, right? We're using these math words.
Okay.
Like X, we can't cut out more than 10 inches from each side of a 20-inch
Okay.
cardboard piece. And then make your Y max definitely go up really high. So I went up to 600 because we want to go bigger than the 484, which was our Y1.
Okay.
So do you see it now?
Yeah.
Okay. All right.